Hey everybody, my name is Jake Everhart, and I'm a software consultant at Keyhole Software. And a few months ago, I wrote my own interpreted programming language called Donut. And I had a lot of fun doing it. It's probably my favorite side project that I've worked on so far. So I figured I would try to bottle up some of the more interesting pieces and talk about them here. Today I'm going to briefly talk about how it works, how I made it, and why I think it was so much fun. So that's my premise, kind of a sales pitch for doing this yourself as a side project. But before we get started, let's talk about burnout. We all know about burnout. I would hope that we all have our own way of handling it. Mine is to find a side project that I like and just fixate on it. Just pour all of my spare time into it until I'm bored, and then usually by that time I'm back to normal. A few months ago, I was feeling pretty burnt out, and I was watching a Twitch stream one night where some people were following along with an ebook for writing their own interpreter using Go. And it seemed really interesting. They were having a lot of fun with it, so I did what I'd like to think any engineer would do in that situation, and I stole the idea for myself. But I also wanted to learn more about Rust. I really like Rust as a language, I'm just not very good at it. So I figured I could use the same designs from the book, but just write them in Rust instead of using Go. Because what better way to learn a language than to use that language to write a new language using a book written for a different language? So that was my plan. But what does it mean to write your own language? It kind of depends on what type of language that you're going for. A compiled language versus an interpreted language. For a compiled language, you've got compilation, translation, optimization, just a whole bunch of extra complicated stuff that I'm going to ignore. For an interpreted language, on the other hand, you're just writing an interpreter, which is just an executable. And like most executables, you've got inputs and outputs. The difference here is that your inputs are your source code, and your outputs are whatever you want your interpreter to do when it sees that code. Okay, so writing an interpreted language means you're writing an interpreter. How do you write an interpreter? I'm just going to give a high-level overview here, but you can kind of think of this as three main components. First, you have your Lexer, which breaks your source code down into tokens. Then you have your parser, which takes those tokens and then builds them up into an abstract syntax tree. And then you have the evaluator, which traverses through the nodes in that AST and actually does the evaluation on them. Over on the right, I've got Hello World shown as an example. So you see the source code for Hello World from Donut, and then you see what it looks like broken down into tokens, and then the AST representation for it, and then finally you get the standard output for running Hello World. This shows the different parts, but it doesn't really talk about how they work. I'm going to touch on each one of these in just a little bit more detail. Starting with the Lexer. As I mentioned, this turns your code into tokens. So the main question it cares about is, do I recognize these symbols? I've got a couple examples here. Neither of these are valid. Both of these would produce a syntax error in Donut when you run them. But that's not the Lexer's job. The Lexer just cares, do I understand what symbols that I'm looking at? For the top one, at least, all of those characters are legal in Donut. They don't mean anything in that order, but the Lexer is able to turn those into a list of tokens just fine. Conversely, I never wrote anything for tilde or question mark or the @ symbol, so if you feed those into the Donut Lexer, it says that those are illegal and it spits out errors instead. As you might expect, these are pretty easy to write. These are pretty simple. You just loop through your inputs and map them over to your tokens. There's not a whole lot going on behind the scenes. But that's your Lexer. And then that feeds into the parser. This is a little bit more complicated than the Lexer, but the main thing it cares about is, what do these tokens mean? Here we've got our examples again. For the Hello World example that we saw up at the top, we know this is valid syntax. We saw it earlier, so we would expect that this produces a valid abstract syntax tree. And it does. You see that this is a call expression. It recognized that it's the puts function and that we're using a string for hello world as the argument. So it's able to build out that data structure okay, and then move on and keep going. The bottom example, as I mentioned earlier, is not syntactically valid. So when you feed that to the parser, it has no idea what you're talking about. Those tokens don't make sense in that order, so it just throws an error and then gives up. It doesn't need to go any further. Lastly, we have the evaluator, which is a little bit more complicated than the parser. The main thing it cares about is, how do I resolve these AST nodes? So here's our hello world example again. If you remember, we recognize that this is a function call, so the evaluator sees this and says, okay, how do I handle a function call? Is this a function that I know about? Has it been declared previously? Maybe it's built into the language. What do I do for the arguments? In this case, it's just a string literal, so it's able to just use it just fine, but maybe it's a variable that it has to go look up. Or maybe this is some nested function call that it needs to recurse down into before it finally gets its evaluation result back and is able to continue on with the evaluation of this node. At some point, it'll finish evaluating whatever node that it's on, and then it'll move on to the next one. And then it just keeps iterating through until it reaches the end of your program, and then everything is done. So, that's how the evaluator works, and that's the last piece of writing your interpreter in like those big 3 components. So now everybody knows how to write their own language, right? I'm kidding. The book does a much better job walking through this stuff. I'm just breezing through this at a high level because I want to get to the fun stuff. The reason I had so much fun with this project is because it's kind of a choose your own adventure type thing. If you want to, you can just follow along with the book and write the same language that the book wants and go no further or no less. And that's perfectly fine. That's awesome. But if you choose to, you can kind of tweak things as you go along. You can make your own decisions and you can really decide what you want your language to turn into as you go. As an example of this, the most obvious benefit of writing your own language is that you get to make all of the syntax decisions. Let's talk about this thing. You see that single equal sign up there where you're not sure if that's a typo or if somebody's trying to get fancy and use the evaluation result of that assignment as their condition in that expression? I hate that. It makes me sad. It makes me upset that that works in some languages because you can forget to write a double equal sign there and your compiler might not save you, and that could be a mistake. So since I hate it, and since I find that as a pet peeve, in Donut, that's a syntax error. You can't do it. If you want to use a single equal sign somewhere in Donut, it had better be for declaring a value with a new variable using a let expression, or reassigning a value to an existing variable using the mute keyword. That's just a pet peeve that I decided to throw into this language. And if you're writing your own language, you can bake in whatever pet peeves that you would like. Do you hate using semicolons everywhere? Make them go extinct. What about using curly braces for all of your code blocks? Maybe you like the way Python looks better. What about implicit returns at the end of your functions? These are all pretty controversial topics, but you can make these decisions and put them in your language. You can upset whomever you want. Another fun thing is adding built-in support for whatever you want. Normally, users have to define their own functions before they're able to use them. You'll see here we've got an example where we're declaring an add function before we're invoking it. But if you want to, you can build stuff like that into the interpreter itself so that people don't have to define those functions. And since you're writing those into the interpreter using a real programming language, you can add support for a whole bunch of fancy stuff. Anything that you can think of that might take a whole lot of syntax in other languages, you can choose to make really easy in yours. Some examples might be file I/O or HTTP requests or converting between different data types. You can decide to make your language really good at whatever you want. Another fun thing is you can decide to build out whatever tooling you want for your language. As an example, I really like how languages like Python have a REPL, which is a read, evaluate, print loop, where you can just boot it up and play around inside the language environment, just try out different pieces of syntax and make sure things are behaving the way that you expect them to. So I decided to expand on that a little bit. This is Do, the Donut interpreter. And it's kind of a lot to look at, but basically the source code and your evaluation results are over on the left-hand side, and your standard output is on the right. This will make a little bit more sense in a moment. I've got a couple videos of it in action. So you can see here, I'm typing lines of code, and as I hit enter, they're moving down into that history section. And that's not evaluating anything yet. This is just where you can move your cursor around and edit these lines or delete them, just kind of edit things there. But eventually you'll say, hey, evaluate, and it'll run through and evaluate all of these lines up to wherever your cursor is. It's just something I thought would be neat, so I decided to build it in. I also wrote a way to import code snippets. You use the sprinkle keyword to import code into Donut programs. You'll see here I'm sprinkling in greeting.donut, and then I can use the greet function. So this means that Donut programs will have sprinkles on the top for all their imports. You write the language, you write the puns. Those are the rules. Anyway, these are a few of the reasons why I had so much fun with this. And as far as side projects go, it seems like this one has been pretty successful. So far, every one person who has used it has really enjoyed it. I don't care if that's just me. I had a lot of fun writing it. I've got some links here for some of the resources. Writing an Interpreter in Go by Thorsten Ball is the ebook that I was talking about earlier. This is a really good book. I highly recommend it for anybody who's interested in looking at something like this for a side project. It's only about 200 pages long. It's really good at explaining things, and it's really easy to pick up and work for a little bit and then put back down. Very low barrier to entry. I've also included a link here for the Donut source code repository for anybody who wants to take a peek and see just how bad I am at writing Rust, or if you just want to make the title of this presentation into a lie. Thank you.